is what I wanted to show you last time. This is where all the information for the course is going to be. This is the course website. So you got the syllabus there. We won't go through that again. Your lessons, here's what's coming up. So we did the introduction badly last time. Today is going to be data acquisition. A bunch of this I think is going to be review, but that's okay. I was looking through some stuff from MEE443, and it looks like you've seen the rivals before for data logging. So I'm going to show you how to use them, just on the fear that in 341 they had you come in, everything was set up, and you just went clink and press the button. So we'll talk about the settings and how to change stuff and all that good jazz on the rivals. Okay. And then we'll get into our homegrown data loggers and Crosby machine controller. So next week we'll play with semiconductor electronics, diodes, transistors. How do I turn something on? How do I power something? We'll be doing all that jazz. Then we'll be doing thermistors and thermocouples. We'll do force and strain. We'll do encoders. We'll measure some pressure. Go party on spring break, we'll come back, we'll do homing and proc switches, we'll do a homegrown PID loop. I'll show you how to hand code a PID loop. Then we'll look at some motors, we'll look at communications, and lastly will be financial planning stuff. Talk about compound interest, 401ks, pro forma budgets, all that stuff that you're going to need as soon as you take your mortar board off. So, that's what it's looking like. This is the general format of how I'm going to do things. So I'll put the presentation here, and there's going to be at least one demonstration every class on that screen, I hope. This will be, the instructor's nightmare, doing live demonstrations, but we're going to do it because that is the best way to learn something. Okay, so on your lesson, these are all just linked up to a Google Drive. For those of you I tormented in 120, this should look very familiar. Any supporting files that go with the lesson, I'll put them right there. So if you guys want to play with the Crosby machine controller, if you think it looks cool, you can download it right there. Okay, data acquisition. Let's start really simple. And you guys are probably going to go, oh my God, I can't believe he's going to say this. Multimeter. Every one of you has probably played with one of these things. You would be amazed at how many times I've seen these used badly and blown up. Okay. What is the characteristic of this thing when I'm measuring voltage? Oh, you guys haven't had coffee yet. This is not good. High impedance. Okay? When I'm measuring voltage, if I were to measure the resistance across this device, it is very, very, very high, like in the mega ohms of resistance. And that's simply so you don't load up your circuit and bog down whatever signal you're measuring. You don't want to add any other circuit pathways by putting this thing on. Okay. The other thing, never, ever, ever use this thing for fast changing signals. Okay. This thing is going to give you an average voltage of about every half second. I cannot tell you how many times I've seen people looking at digital signals that are moving at like 10,000 bits a second and thinking they're going to get smart, accurate information out of this thing. Ain't happening, guys. Okay? So don't ever try to measure a digital signal. And that could probably be something like one of your RC controllers. Okay? Don't do it. It's not going to happen. Okay, the other common way to use this thing. Let's say you're going to measure current. You're going to measure amperage. You're going to use it as an ammeter. What is the big, important attribute when you're running this thing as an ammeter?
You run it series circuit.
Absolutely, got to run it in series, but it's very, very low impedance. Okay, when this thing's acting as an ammeter, imagine that there's just a piece of copper wiring back there. Okay? So that current can flow right through without affecting your signal appreciably. Okay? Do not put this thing in amp mode or current mode and try and measure voltage. Okay? Because you will hear a pop, a sizzle, and there will be smoke coming out of it. Okay? You will have huge amounts of inrush current for a few seconds right before the fuse blows. And every year I have to change the fuses in these things after capstone, which is why I'm actually saying this. Okay? So be careful when you're running in amperage mode. But they have their place. Okay? If you're just trying to measure, do I have 12 volts from my power rail? Perfect application. Okay? So if you're going to use it right, go like that. You got it set on volts, you measure it across the resistance, you're going to get some voltage. Cool. And we're actually going to do exactly that, but what we're going to do is have R1 as a shunt resistor. So by measuring the voltage across the shunt resistor, we can use Ohm's law and we can get current that's actually flowing through that leg of the circuit. Okay? So to your point, if you're going to run it in ammeter, put the thing in series. Put it right in the flow. Okay, once you do start getting digital signals, fast-moving signals, maybe you guys want to trigger an event and you want to capture it. Okay, the Rigels are the way to go. And I just happen to have a Rigel set up with a signal source. Now I'm going to simply put that on auto. So if you come in and you're trying to do your experiment, the easiest way to deal with the Rigels, just come in, put the leads on, hit the auto button right there, okay? It will do its darn fine best to find the best voltage per division and time interval per division. Once you do that, however, you can change it. So if I want to, say, move the position, I can move it up and down with a little knob on top. I can take and change the time interval. Oops, excuse me. That was the volts per division that I was accidentally hitting. Okay, so I can make it taller, shorter, whatever the case. I can stretch out the time interval. Move it around. So let's see what our voltmeter says the voltage is on that. Just because I'm curious now that I gave that warning. 4.92 volts. Yeah, probably not. Okay. So again, fast changing signals, do not use this thing. Just in case you're wondering, that's an Arduino saying hi to you. That is what the TTL signal for hi looks like. That's 2 letters. Okay, and we're going to talk about that when we get into device communications. And I'll show you how to actually set up every one of those highs and lows. Okay, so that's cool. And we can mess around all we want. I just happen to make this thing so that there's actually a quarter of a second interval between those bursts of data. Okay? You're never going to see that with any other device except the scope. Don't be afraid of these little things, guys. Okay? They're pretty bulletproof. As long as you just come in, put the leads on, and hit auto, it's going to give you something pretty decent. Another piece of advice, or another public service announcement. What I'm doing is I'm setting this up a lab in Crosby 100. So I put in a bunch of grad desks, and I'm going to put out oscilloscopes. I'll put in Crosby machine controllers. I've got a bunch of retired computers that I got as old cluster computers. And those are great. So if you want to experiment with shifting power and switching stuff and doing all that kind of jazz, do it on my beater computers. Okay? They're at their end of life mission. If you accidentally hook up 24 volts to the USB port on those and smoke curls out of it, I don't care. That's fine. If you do it to your laptop, I really hate to see seniors cry. That's just not, it's not a good thing. All right, so when you come to do your experiment, Crosby 100 will be open during normal business hours, Monday through Friday, pretty much 8 to 4:30. So feel free to use that. Okay, so you can switch it up and down. You can change the volts per division. That's all great. But the nice thing about the right volts, which you probably saw in 341, was that these can output your data for you. Okay. So let's try doing storage. I'm going to get a picture that I like a little better. Okay, I'm lost. I admit that. I'm just going to hit auto. Cool, there's my signal back. Great. And let's go over a little bit. And I've got all my signal on the screen. Great. Let's data log that. So I'm going to come in with my handy dandy flash drive, which I always have to put upside down and never remember that. But that's okay. And I'm going to hit storage. One of the things you got to do, folks, if you want a waveform, make sure you choose comma-separated values. It's going to make it much, much easier for you to deal with this in MATLAB, Excel, whatever your choice of number crunchers is. Okay, so I'm going to choose CSV, and I'm going to choose external. I'm going to choose new file. And I am terrible at using these little screens. I mean, it's kind of like my cell phone. I can't text either. It's just, you guys are better at that. Okay, so I'm just going to hit save. And voila, it writes out the data. Okay, we'll pop this thing out. Put it in my laptop. And personally, I'm an Excel junkie. I'll go down to USB drive. File 001. And there is 600 lines of data that we can now mess with. And just to prove to you that yes, in fact, it is the same thing. And there's our TTL signal, ported over into Excel. And now, of course, you guys are gonna properly resize the axis. You're gonna make sure that all of your axes are labeled with units. Okay, that's gonna be something I'm gonna be really, really fussy on in your reports. So, go ahead and make sure that your data is all nice and clean. But there you go, it's that easy. So if you're doing any kind of fast stuff, okay, you got 600 data points. And with the Reingold, you can go to, I think it's like 5 seconds per division, something like that. Okay, so your memory's gonna run out pretty quickly. You don't have a lot of time. When you want to get into longer stuff, folks, if you want to figure out how much energy your solar collector is going to gather over a 24-hour period, okay, that's when you want to think about the Crosby machine controller. That can literally run for days or months, logging data at whatever interval you want. Okay, the other thing that the Rheingold's are really good at, which I don't know if they showed you in 341, is let's say that you want to have a triggered event capture. A couple of years ago, I had some students, they wanted to test the durability of the landing gear on their drone. So what we did is we picked the drone up in the air, we put the Rheingold's on trigger at a certain input voltage, and we just dropped the thing. And we looked at, what was the data as that fast event occurred. Okay? So we need a fast event. What do you know? It's an electric motor. Just happened to be here. I think what I'd like to know is, what is the transient startup on this motor? So, is there going to be a big inrush on startup? Is there going to be, I don't know, maybe this thing acts like a big old low-pass circuit, a big LR circuit. Maybe the coils don't charge up that fast, quote unquote. Okay, so let's hook this thing up, and I'm going to set the Rheingold to trigger at a certain voltage, and we'll see what happens when a motor starts up. So I will get this junk out of the way. Positive lead on there. Oops, actually got a positive lead. And I'll put the negative lead with the Rheingold. That. So let's change this thing up so that we put it on capture on trigger. So what I'm going to do is I'm going to come right over here to trigger and hit the menu. And instead of having sweep down here, what I want to do is I want to put it on single. Okay, that's going to activate triggering at a set voltage. So the Rigol is going to be sitting there writing data, writing data, writing data in a continuous loop. Right up until it hits that trigger voltage, and then it's going to say stop. Save everything I've got. So let's see, I'm going to set my triggering voltage. So that dotted line that's moving up, that's my trigger. That's when everything's going to stop. And channel 1, my volts per division, that's way too low. Let's put this up. More like a volt. And the time is way too short. I want to go to 10 seconds. Okay, so when I hit the run stop button, now she's gathering data, but it's just sitting there waiting for that trigger event. Okay, so let's trigger it. Hopefully we don't have to call any psychiatrist. Okay, I was out of range. And that's fine, I kind of knew I was going to do that. So let's see if we can actually, find the data. Okay, so I got the data, but it's not very good. So let's have a little bit longer duration. And I'm going to go with 2 volts per division. I'll hit the run stop again so it's ready to trigger. And all right. So look at that. So we've got a big inrush current. When that motor is sitting there with no spinning rotor, it's acting like just a giant piece of wire. Right up until everything starts spinning and we get some back EMF. And then that's going to lower your current going through the motor. And let's see if we can make this look a little better. So I'm going to move this down a little bit. Triggering over here, and go with 1 volt per division. Ready to run. There we go. So we've got a big inrush current, the motor starts making back EMF, and the current drops right off. And now we could export that data the same way. And we could actually calculate the running current through the motor based on the value of this thing. So I had alluded to shunt resistors. Okay, this is a little half ohm resistor. This is a known resistance. So So by logging the voltage across it, now I know the running current. When I really want to get big and ugly, I can get a shunt resistor like this. Okay, this is a 100 amp shunt resistor, which to me looks like a bandsaw blade with a couple of pieces of brass on the end. Okay, when you really want to get big and ugly, come see me, I'll give you one of these. We were using these for land drone startups, and they did a pretty nice job. Okay, so Rygold's really cool for fast-moving signals or something where you want to do triggering on a voltage. Okay, that's your instrument of choice. When you want to start doing long duration stuff at not super high speeds, that's where the Crosby machine controller comes in. So let's change this up, and we will data log some stuff with the Crosby machine controller. Crosby machine controller is actually cool because not only does it do data logging, but it also handles power. For those of you that had me in 120, okay, more Jeep parts. Yes, that is an actual Jeep headlight. And I have a power MOSFET. It's actually going to be the muscle for this project. And you're going to learn about those next week, so you will be able to do exactly what I am about to do. The power lead broke off, so I'm going to just hold it. Minimize that. So if you want to use the Crosby machine controller, what it does is it has a USB connection to a PC. The PC is always the master. It tells the Arduino when to talk. So it will actually issue commands via USB to say things like send the analogs, send the digitals. It actually writes SASD onto the USB line, and then the Arduino responds. Or it can say, set the digitals as something, or set the analogs as something. So in order to make it go, the first thing we have to do is we open up the Arduino IDE. We skip the updates in class. Okay, and you're going to use what is the Crosby machine controller V4, and you're going to shoot that into the Arduino. I'm not going to do that right now, just because I don't want to screw up my demonstration if anything goes wrong, and you don't want your time wasted. Okay, so I shoot that into the Arduino, everything goes great. Next thing you're going to do is if you download this Crosby machine controller, you will see the Arduino stuff is in a folder, and the Visual Basic program it's written in is in the same folder. Now, this is written in Visual Basic, which is part of Visual Studio. Visual Studio is free to students and educators, so you can just download it free of charge. The only thing you gotta do is have a Microsoft account, which is totally fine. And then, if I open Visual Studio, okay, this is a programming environment. I'm going to open my Crosby Machine Controller V4. And you get to something that looks like this. Okay. Do not do anything here. The only thing you want to do is press Start. Start executing the program. Okay. This is your actual Crosby Machine Controller. And we're going to start off by establishing communication with the Arduino. So you got to choose the COM port that the Arduino's on and hit connect. Yeah. Let's try that again. Usually it's the highest number COM port. Okay. All the communications that are happening go on in that window, which is cool to me, but it doesn't really mean anything to you. So I actually wrote this. So you have things like graphing windows in here for A0 on the Arduino. I've got a pot hooked up to A0, so if I turn the pot, I can change the voltage going to A0. You can reset the chart data if you want. Okay, but the important thing for you guys is going to be the start data logging button. So it says, where do I want to put the output file? And I'm going to put it as, let's see, I'm going to call it demo, and I'll hit save. So now it's writing to my output file every half second. And you can change that data writing interval. You can go down to 25 milliseconds between data writes, which is pretty fast. Okay, so again, I'm going to do A0 just to show you that. And all of this A0 stuff that I'm doing is being written to the hard drive. And we also have outputs. So let's see. I see one broken wire, which should not be broken. So I've got, you can also do output control. So I should be able to grab the slider, and what you should be seeing is the headlight comes on brighter and dimmer. But unfortunately, with broken leads, that's never fun. All right, worst case, I'll owe you that one, and you will see it. You can also watch it on the, I embedded some videos. Maybe I'll also show it to you when we do transistors. Okay. I blew it, I admit it. But okay, we've been writing a bunch of data down. And let me show you what comes out of the Crosby machine controller. So if I say end data logging, close that. And I've got my demo CSV. I made it so the Crosby machine controller writes out not only the values on all the analogs, okay, but also the digital states, and you can also do servo outputs. So for those of you that are doing things like drone stuff, okay, you can take this servo output right off the Arduino, and you can run that into a drone motor controller, and you can rev a drone motor up and down with that, which could be pretty snazzy. So if you want to do something like revving your drone up and looking at, okay, what does it, how much thrust does it make per RPM, something like that, that'd be an excellent experiment to do. Okay, you can drive it with this, and you could have the Crosby machine controller data logging the load cell output, measuring the thrust. I had to write down the actual date and time from the PC's clock. And this test time, that is the duration into the test from when you hit start data log. So let's get rid of that much. And let's get rid of that. So again, there's A0 for the entire time that the data logger button was actually pushed. Okay, so if you're one of those guys who says, you know, oh, I can't do anything without National Instruments stuff because I work at the Composite Center, okay, feel free, you'll be on your own if you use that. $10,000 worth of data logger will actually do the exact same thing as $20 worth of Arduino. So, very cost effective, and if we blow it up, not a huge deal. Okay? So if you need to log information out of an Arduino, Crosby machine controller is an excellent way to go. If you want to watch this little chunk of unhappy video, it shows you some of the other things. So I hooked up a little servo on that. You can actually watch the servo go back and forth. But it's not going to show you anything that we didn't do. Okay, if you need Visual Studio, the link is in the presentation, it's right there. If you need to download the Arduino programming stuff, it's right there. One thing, guys, I use the generic knockoff Arduinos. They will need the CH34X serial driver. A lot of times, people that have been using the actual Arduino can't hook up to them. So this is in the cheat sheets and resources folder of the class website. And that's all the stuff I just did. All right. That was a lot of stuff. I'm sorry that headlight demo didn't work. I will have that ready for next time because now I've been challenged and I don't take challenge loss as well. All right. Any questions, guys? Any issues, questions, comments, concerns? If you do not have a group to work in, please send me an email. Okay, we're going to do all of these in groups. Generally groups of like, whatever your capstone is, or groups of like 3 to 4. So if you need a partner to work with, let me know.